Overloading a queue can be a nightmare. Network calls such as HTTP that are normally quick suddenly take 10 times as long and can increase processing latency dramatically. I'll show you an example of something I've dealt with personally and how to avoid it. Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to my channel, I post videos on software architecture and design and in .NET. So if you're into those topics, make sure to subscribe. All right, so for a quick setup here, I have my loosely coupled monolith project I've been using in all my videos. I'll have a link to the description. And I have a combination of Hangfire and Mediator being used, but the point of this is to actually be running jobs in the background. So I have this ASP.NET Core controller with this action, where what I'm going to be doing is I'm going to be creating this place order and I'm going to be enqueuing it. So what's going to happen here is that this is going to occur in the ASP.NET Core project. Once Hangfire enqueues it, I have Hangfire server running in this worker, and it's ultimately going to pass that request off to Mediator, which is going to run this handle method. So I have two different processes. This work's going to be done out of process in the worker. So what I've added in this handle method, it's kind of just a dummy here, but what I have is I have this exchange rate, and I have this call to get current rate. Sitting behind this is I'm actually using HTTP client to fetch out an exchange rate just to some mocked out service that I have that's just going to return us the value. So it makes this call. It's going to deserialize it into this object for this class, and then as if we were going to use it for some purpose here, attach it to the order, whatever the case may be. But the point of this, again, is that to illustrate that this handle method is being done out of process, and underneath the hood, we're actually making an HTTP call from it. All right, now what I'm going to do is run the app, and then I will go in Postman, make a few requests to the place order route, and then we can go look at those jobs that were created in Hangfire to see how long they're taking to run. So let's jump over here. We'll fire a few of these off. All right, let's look over at Hangfire, refresh this. So there's 4 of the jobs that I just ran. If I go to succeeded, I could see how long they took, and the total duration was 763 milliseconds. So in our case of overloading the queue, what can actually happen here is that we have producers providing so much work that our consumers can't keep up. And that could be just by the sheer volume of actual work being sent by the producers, but it also can be by us, what normally would take, for example, that 600 or 700 milliseconds, all of a sudden drastically takes longer to perform that work. And if you have a fixed number of consumers, this can be a problem. So the culprit here, and where the danger lies, is in this HTTP request. By default, the HTTP client has a 100-second timeout, which is not ideal. So what happens if this particular exchange rate service that I have starts taking abnormally long, or takes over the 100 seconds, where finally the HTTP client ends up calling a timeout, the job will fail, and then it will be put into the retry queue. So if you look at the exchange rate service, for example, let's just put a delay in here to kind of mimic it taking a long time, and we're going to do 110 seconds. I'll restart it. Then we will jump back over to the loosely coupled monolith, which we are still running. So I'm going to go back over to Postman. Let's make some calls here. Make a pile of them. We can see that they're actually returning really fast. However, if I jump over to Hangfire, our current limit is set to run 5 jobs, 5 basically worker threads. So this is the most that we can actually process at any given time. That means that all the jobs that we keep sending in, that our producer keeps creating here, are just going to be waiting. They're going to be waiting until these actually fail out. And that's going to take 100 seconds for that to actually happen, which is not ideal. So the way to deal with this, there's a couple different ways. Is one, you need to add more consumers. But that's not going to really help when you have an HTTP client that has a 100-second timeout. So a naive or simple view of this is just to simply add a timeout to our HTTP client. And that may actually be the simple answer and the solution. Another option is just to simply stop having producers produce messages. So if we go over to place order, it's really about even preventing this from even occurring. So we're not overloading the queue even more with work that needs to happen. So a library you might want to take a look at is called Poly. So it obviously does timeouts, what I've been talking about, but it does a lot of other cool stuff like retries, circuit breakers, and one really important feature here when we're talking about timeouts is fallbacks. So in the case of our call to this exchange rate service, if this were to fail, we could wrap a fallback around it to provide some value, maybe that we have a local value cached, and this is only for trying to get the most up-to-date exchange rate, but we always have a cached version just to keep the caller, place order, satisfied so it can actually execute quickly. So when we're talking about an overloaded queue, there's really three options. You have add more consumers so you can process more work, reduce the number of producers so you're not producing as much work, or three, which is really about increasing the processing latency. And not even that, so much that, but realizing the work that you do have, it may normally, under great circumstances, run at a kind of a latency that you expect, but there are outside sources, things like network calls, that can unexpectedly increase the processing latency, which will ultimately overload your queue. If you have any thoughts or questions, make sure to leave a comment. I really do appreciate them. If you enjoyed this video, please give it a thumbs up. And if you're into .NET, software architecture and design, please subscribe. Thanks.